Okay, we are back again looking at data representations. Today we're going to look at two different topics. First, we're going to look at how to create what is referred to as a 5-number summary, and then we're going to look at how to read and interpret a box plot, as well as how to create those box plots using Desmos or a similar graphing calculator. Let's go ahead and take a look. To get started here, we're going to refer back to that tomato plant data that we used to create our histogram in the previous video. Once again, this is referred to as numerical data, meaning it's number data. It's data that represents the number of days it takes for a tomato plant to produce fruit. Previously, we looked at this data in terms of its frequency. However, today we're going to look at the data as one large group. I'm not interested in breaking it into frequencies. The next section of our paper refers to a couple of different values that we are going to need to calculate. First of all, we've got the minimum value, followed by quartile 1, then the median, quartile 3, and finally the maximum value. Now clearly, if our data is not organized in numerical order, it can take a little bit of time to calculate these specific values. However, luckily, we are able to use Desmos to do this very quickly. Let's go back to that Desmos worksheet from the histogram video. Once you have the Desmos worksheet open, we're going to look again at this list. Again, the list was generated by typing capital L equals, then use a square bracket and simply type in all of the data points in the set separated by a comma. We have all of the data from the tomato plant table already typed in. I'm going to look now at the second folder, which says Open to View Measures of Variation. Clicking on the arrow, this opens up all of the contents of the folder. Now Desmos can quickly calculate the minimum value of a data set. You simply type in the word min, followed by parentheses, and in the parentheses you're going to reference the list that you would like to find the minimum of. Since our list of data is the capital L list in line 1, I just type in minimum, parentheses, capital L, close parentheses. Down in the output section here, it shows this equals 47. So in other words, the minimum value in the data set is 47. Similarly, I can find quartile 1 by typing the word quartile, followed by the parentheses, L, comma, 1. And this tells Desmos that I'd like to find the first quartile of the data set, which happens to be 62. For the median, I just type median, again referencing the list, capital L. For quartile 3, I type quartile, L, comma 3, 3 meaning the third quartile. And finally, for the maximum, I just type max, parentheses, L, close parentheses, and I have my output for each of these. I'm going to go ahead and make a note of these values on my paper. Alright, from here let's answer a couple of questions. First off, what does the median represent for these data? Well, the median is literally the middle value of our data set. We have to place our data in order from least to greatest to find the median directly. However, software such as Desmos or other graphing calculators can find the middle value without us having to organize the data ahead of time, which is very helpful. The next section says the median of the lower and upper 15 values splits the data into first and second quartiles. What do these values represent? Well, the median is the middle of the data set. This means over here on the left-hand side we have the lower half of our data, and over here on the right-hand side we have the upper half of our data. Quartile 1 literally splits the lower half of the data set into two halves itself. It also serves as the median of the lower half of the data set. We could think of quartile 3 similarly. Quartile 3 is the median of the upper half of the data set. Once we've found these values, an interesting organization scheme emerges. From the lowest value to quartile 1, we have 25% of our data. From quartile 1 up to the median, we have the second 25% of our data. From the median to quartile 3, we have the third 25% of our data, and altogether we've accounted for 75% of our data. Finally, from quartile 3 up to the maximum value in the dataset, we have the final 25% of our data. This is what we mean when we say that we've split our data into quartiles, quartile meaning 4. One more quick thing before we keep going. These 5 values together are often referred to as a 5-number summary because they are key measures or descriptors about how varied or how spread our data is. We're going to use these 5 numbers together to construct a box plot by hand. As with the histogram, you're welcome to follow along with me on your paper, or you can just watch to see how it's done. Alright, I took an extra moment to color code things so that we can see what's going on a little bit more clearly. To start with, I want to point out in blue, I have shown the minimum and the maximum values. Then in the center, I've shown the median in blue. The horizontal bars in purple show the distance between the minimum value and Q1, as well as the maximum value and Q3. In red, we see Q1, and in orange, we see Q3. Now, one of the things that you'll want to be careful of when you're reading a box plot is understanding that the gap between the minimum in Q1 as well as Q1 and the median in Q3, and Q3 and the maximum is what we're actually interested in determining whether the data is symmetrical or skewed. Generally speaking, if the box plot itself is symmetrical, the data itself is most likely symmetrical as well. However, if we see that one of the whiskers in the box and whisker plot is significantly longer than the other side, then that may indicate that our data itself is skewed. Something that can be a little bit challenging to visualize is the idea that exactly 25% of the data lies in this region, 25% in this region, and in this fourth region. Even though they're not the same width, it's still true that 25% of the data points in the set lies in each of these regions. The width of each specific section shows how variable that section really is. So in other words, we see a little bit more variation from the minimum to the median compared to the median up to the maximum. In other words, the data points are clustered together more closely from the median to the maximum value when compared to the minimum in the median. As with the histogram, we're generally not going to build a box plot on paper. However, it is important that you're able to read and analyze a box plot, and it can be very helpful to be able to build a box plot using a graphing calculator such as Desmos. We'll look at how to do that now. I'm going to close the folder that indicates the measures of variation. That's the 5-number summary: minimum, quartile 1, median, quartile 3, and maximum. I don't need to hide anything because those are just calculations. And then I'm going to open the third folder here that says Open to View Box Plot and toggle the view on. When I do this, I'm going to choose Zoom Fit so that it fits my screen. Now we have a digital representation of what we just made on paper. I'm going to zoom in just a little bit closer. Now that I have the box plot centered, let's look at how you could create this yourself. To build a box plot, just type in the word box plot followed by the parentheses and the uppercase L, which references that list of data that we created on line 1. There are a couple of properties that you can use in Desmos to change the view of the box plot, but overall there's not a lot we can adjust here. The offset option adjusts how far off the x-axis that the box plot is situated, so I'll switch it from 1 to 3. The height setting adjusts the actual height of the rectangular box itself. Let's change that to 3 as well. Both of these properties are purely aesthetic and they don't change the function of the box plot in any way. I'll put them back to default. Alright, let's test our knowledge and see how we did. For this last section of our paper, it says identify the key features from a box plot. We're going to complete the 5-number summary using the given box plot on the number line. Let's start out by finding those minimum and maximum values. The minimum and maximum values are found at the ends of the box plot. The minimum for this particular box plot is 2, whereas the maximum is 9. The median is found at the center of the box plot itself. This time the median appears to be 4.5. Quartiles 1 and 3 are located on the left and right ends of the rectangle respectively. Quartile 1 is 4, whereas quartile 3 is 6.5. And there we have it. We've got our 5-number summary found from a box plot. We've also seen how to find a 5-number summary using technology, using Desmos specifically. And of course, if we needed to, we could calculate these values by hand if we organized our data from least to greatest. This wraps up our discussion of data representations in terms of box plots and the 5-number summary, which is often featured with box plots. In a future video, we'll take a look at the shape of data distributions and how to analyze data that takes on various shapes.